Okay, guys, here we go. This is the second part of the log properties conversions video. So I think this, yeah, I called this video 5. Express the equation in exponential form. All right, so guys, this is, they just want you to convert. Where it says express the equation, the reason they call it an equation is there's an equal sign in it. So, I'm just going to grab one right here like this and say, all they're asking you to do is say, hey, in exponential form, the base stays the base, the other two flip-flop. That's it. That is all they want from you for the first part. So this part here was covered in the last video. Then, take a look at these ones right here. It says express the equation, because there's equal signs in these. It says express the equation in logarithmic form. So like this one right here, they want you to convert. So I would say the base stays the base, but it's going to be a base 7 log, and then flip-flop. All they're asking you to do is convert. They're not asking you to solve or anything like that. So when it says express the equation in logarithmic form, all they're looking for is conversions. So I'm going to do just one more, because this guy maybe with the E there, you might go, what the heck? Just remember, that just means it's a log base E, and if it's log base E, we don't write it like log E. We write ln, and then the other two guys flip-flop. And that would be the answer they're looking for that one. So, as you can see, I have already done 3 of these, and you might be looking at this saying, that's a lot of work. Well, you ain't seen nothing yet. But do not worry. All they want you to do is practice converting and practice recognizing properties. Take a good look at that thing, because that is a property. You don't have to punch that into your calculator. You don't have to do anything special. All you have to do is go, wait a minute, I saw that in the last video. The answer is 2. How much work do you have to show for that? None. The answer is 2. Also, something like this. Anytime I take the log of 1, no matter what the base is, if I take the log of 1, the answer is what? 0. How much work do you have to show for that? Absolutely none. Now, the thing is I want you to do all these based on your knowledge of properties. So, if you know what you're doing, you already have the answer to that one. You have the answer to that one. You got that one. I gave you these two, but what about this one? See, here's the deal with this. This is a sneaky guy. When it says evaluate the expression, I look at this and I can see that this is log base 4 of 64. Now, I also know that 64 is the same as 4 to the 3rd power. I do. I know that. It's burned into my brain. I'm a math teacher. I got weird numbers in my head all the time. So what's the answer then? 3. The answer's 3. But you might look at 64 and say, I did not think of it as 4 to the 3rd. That is not how I roll. Well, guess what? When you're evaluating these expressions, there is nothing that would say you could not try to trick your calc. I could have punched in log of 64 divided by log of 4. That would have tricked my calc. It would have told me the answer is 3 also. So the thing is, what I want you to do here is practice converting, and yes, you have to do all of these. The good news is you really don't have to show me any work for any of them, because there's no work to show. You just do it. So write down the answer. Then check this out. These are all properties. And you might go, oh man, that's a lot. Yes, it is. But I need you to practice this and get really good at this. So once again, I'm just going to pick on a couple here. But log base 9 of 81. If you do not think of this, you know what? Log base 9 of 9 squared, because that's all 81 is. 81 is the same as 9 squared. My answer is then 2. Well, if you don't see it that way, you don't have to panic. That's what I call a property in disguise. That does not mean you cannot try and do it this way, because that is using your calculator to change the base. It's also going to give you the answer 2. But I'm hoping that some of these that you look at like that, you just know it. And if you don't, that you should just know it. Yeah, you might want to punch that one in on your calculator. You might not recognize that one, or this one, or this one. But you know what? You should recognize that guy. So let me get all these little marks out of here, because you never took a picture of this stuff yet. But I would say, whoops, I might as well get rid of all of that stuff. Hate leaving it undone. So anyway, guys, these are just practice recognizing properties or practicing using your calculator to give you the answer. Every single one of these problems here has just some regular old number answer for it. It really does, like 1/4, or, well, that one's kind of sneaky. What's the answer for that one? Well, I know what it is, but I want to see if you know what it is. And I gave away quite a few of these already. So I'm going to take that off there. But all you're doing is properties or calculator here. Let's call this properties or calc. You will get the answer for those. And guess what? You don't have to show me any work for any of those. Now down below here at the very bottom, you're like, more? There's more of it? Yeah, I want you to try and practice using your calculator. These are just, you're going to get an answer rounded off to 4 decimal places. That's it. Now, here's the thing with this. You don't have to show me any work for this either. You're just going to write down the answer. That's it. Here is the only place that you might have to show me some work. Okay? This is going to require work. You have to show it. But you know what? There's not much work to it, because these are what I call the logarithmic mini equations. This was not mentioned. I didn't go over this in detail in the last video, so I'm going to pick this one little spot up right here. And these are called the logarithmic mini equations. Now, just look at them for a second. And I want you to focus on how a log statement is written. You have a log, you have the word log, then you have a base, then you have a value, then you have something in equals, okay? You have 3 components is what I'm trying to get at. And here's the thing with those 3 components. One of them is a variable. That's what makes this something you have to solve for x. They want you to solve for x, find x. So here's why I refer to these as the 3 different mini equations. So there are only 3 different mini equations. And let's start with the first kind, which is what I call, the first kind is what I call super easy. Why? Because they're super easy. Here is how you recognize the super easy. Log base, I'm just going to put a 2 here. What the heck? Because I don't want to work that hard. And then I put an x here and I put a 5 here or something, okay? That is a super easy log equation. It's one of the mini equations. Here's another one. Log 6 base 6 of x equals -1. Super easy equation. Let's do one more of the super easies. I'm just making these up. Log base 1/2 x equals 2. And you might go, none of that looks easy to me, Mr. Bogushevitz. That does not look easy. Well, let me show you how easy it is. The answer to the first one here, the answer to this one is 32. How do I know that? Because I know how to solve a super easy mini log equation. When you don't know what to do, here's the grand rule. When you're looking at something, you're like, I don't know exactly what to do. Convert. The rule is convert. So change it into the... So what's the base? What's the base? The base is 2. What do you do with the other 2? You flip-flop. And then you go, oh my gosh, you're right. That was a really easy equation. Because x is going to be equal to 2 to the 5th. What's 2 to the 5th? Punch it in your calculator. You'll get 32. That's the answer. Your answer is 32. Move on. But you know what? You have to show me this one little step. I told you on the mini equations, I want to see a little bit of work. But there's not much to show. I know. All you have to do is show me that you converted. See this one? The answer to this one is 1/6. How do you know? Well, the base stays the base, flip-flop. And if you punch 6 to the negative 1 in on your calculator, it's going to give you a repeating decimal. But this just means 1/6 to the first. Because remember, negative exponent just says change my location. You math frac that decimal, you're going to get 1/6. I didn't show much work, but there it is. That's all the work I had to show. This one, the answer is 1/4. How do you know? Well, the base is 1/2. I'm going to flip-flop it. So I'm going to square 1/2. Now, if you square 1/2 on a calculator, you might want to be cautious and put the whole thing in parentheses because you are actually squaring the whole fraction. Your answer is 1/4, though. There you go. Bam. Those are super easy. They are. They're super easy. You just rewrite them and then punch them into your calculator. Speaking of using your calculator, here's the second type of mini equation. Here's the second type. And the second type is what I call the trick your calculator style. Trick your calc. Okay, so I'm going to have a logarithm. Of course, I got to have a logarithm. Okay, that's a given for the situation here. And then I'm going to have something like a base, and I got to have a number, and it's got to equal something, right? That's how it rolls. So I call that a trick your calc style. I could make up a couple more of these. What the heck? I'm going to do log base 3 of 5 equals something I don't know. And I'm going to do one more because I haven't used natural log, but I could do natural log of 4 equals something I don't know. Now you might say to yourself, trick your calc style. Well, yep, I'm going to just grab my calculator because if I want to, I could convert it. I could convert it. Base stays the base, flip-flop. But you know what? Sometimes that doesn't help me. In this one, that might have helped you in this one. You might go, you know what? Doesn't it have to be a 3? Wouldn't x have to be 3 to make that true? And you go, yeah, sure. But you know what? I call these trick your calc because I could also pull out this old trick and say, I know how to trick my calculator into thinking it's base 2. And I could punch it into the calculator, and I'd get 3. The answer's 3. How much work did you have to show? Well, if you went this route, you might have abandoned that, or you might have said, oh, it's got to be 3, or you might have done this thing over here. Either way, there's not much work to show, but there is a little bit of work. Like this one, if I were to rewrite this one, I would say the base stays the base, flip-flop, and then I go 3 to what power is 5? Crap, I don't know. I don't know. Well, that's because it's going to be a weird number. How do I know that? Well, I also know I could trick my calculator into telling me the answer. What's my calculator want to see? It wants to see the log of 5, but it's got to be divided by the log of 3 because I got to trick my calc. You got the rhythm now. So I punch that into my calculator. I do log of 5 divided by log of 3, and I get this super decimal that says 1.464973521. I'm getting tired of writing numbers down. So I got to tell you, what we usually do is we customarily round to the 4th digit. So if I was going to round to the fourth digit, then that would kick that up. Oop, and then it would kick that up. So the answer you'd see in the back of the book would be 1.465, just so you know. If they do not tell you where to round on one of these, usually they'll round to the fourth decimal place, just a custom. All right, well, what about natural log 4? Well, don't hit the log button on your calculator. There is an LN button, and all I'm doing while I'm talking is punching in on my calculator, natural log of 4, and I hit equals, and I get an answer of 1.38629, etc., etc. But I told you we usually round to the fourth decimal place, so should I round it up 1? Yes, I should, because that's a 9. So the answer they'd write in the back of the book is 1.3863, because they round to the fourth decimal place. So let's review real quick. These are the only problems on the entire assignment where you'd have to show me work. And you can already see that these guys right here seem to fit one of the formats I just talked about. And these guys right here seem to fit the other format I just talked about too. So there's one last format, and this is the one that messes everybody up. Guess what? It's not when the variable is here. And it's not when the variable is over here. There's only one other place I could put that variable, and this is the third kind. This is the one that has like a super math sounding name. These are reciprocal power style. Reciprocal power style. They look like this. Log base x of 2 equals 1/4. Something like that. You go, oh, that looks horrible. Nah, it's not that bad. Or they do something like log base x of, I don't know, let's try 27 equals 3. And you go, oh, that looks horrible. And I say, no, it's not that bad. You know why? Because I know what I'm doing. This is the third location where you can put a variable in a log statement as the base. So what do? This one you definitely do want to convert. So I'm going to say the base stays the base, and then I do flip-flop. But here's how easy this is. The reciprocal power. We actually did this before. Reciprocal power. I take this to the fourth power. That means I take this to the fourth power. If I do that over here, everything cancels. I get x equals, and then 2 to the fourth. Hey, I could punch that in on the calculator if I don't know it's 16 already. That's my answer, 16. Yeah, but what about this one? It looks really bad. No, convert it. The base stays the base. Flip-flop. And then you go, well, what do? Reciprocal power. Well, the reciprocal of 3 is 1/3. And then you go, oh, over here it would cancel. Over here it would be 27 to the power of 1/3. Not 27 times 1/3. 27 to the power of 1/3. So if you punch that in on your calculator, you'll get 3. Because this is a cube root. What times itself 3 times 27? 3. What do you want me to do with that 3? Take it to the first power. Oh, it's 3. So, long story short, take a look at this. We've already done the properties. We've already done conversions. This says use the definition of logarithms. That means sometimes you convert, sometimes you trick your calc. Sometimes when you convert, you're going to use a reciprocal power. And sometimes it's just going to be doggone easy. Because sometimes they're called super easy. All right, so guys, this is the assignment that goes with the last video. I didn't put any practice problems in there, but you'll also notice one thing. This is the only time I have done this to you, and I'm going to erase that. The only time I have done this to you, I am not going to give you an answer key. Not at all. Not going to give you an answer key for this one at all. Why? Because you don't really have to show any work for any of these. You could just jot down the answers. So I'm just erasing this noise on the side here. But what I want you to really do is I really want you to see if you can get all these without any of my help. And when we get back together the next time, what I will do is I will go over every single answer with you. So here we go. There's the first set of problems. Take a picture of it. You have to do all of them. Just remember these are conversions. Then, starting here, problems 15 to 24. Well, what do they want you to do with all this stuff? They just want you to recognize whether it's a log property or if you have to trick your calculator. Do I have to do all of them? Yeah, you do. Because some of them should be rocket fast. They should take you very little time if you know your properties. And if you don't, the only way you get better at it is to practice. And if it takes you a little while, it takes you a little while. But there's the mini equations. That's the only place you have to show me a little bit of work. And then this is just skills trying to use your calculator correctly right here on the bottom. Okay, guys, that is the end of the road for this. So good luck to you. And like I said, the answer key, that's coming later. I want to see what you tell me first. Okay, bye-bye.